So for your opener, number one, it's just solving the equation, just like we did in our entire last unit. And remember one thing that I do, we don't always need to do it, but I get one side to be 0, so I subtract 21. So I have to do 3 minus 21, which is negative 18, equals 0. Then I can add 18 back to try to get 6x by itself. 6x equals 18. Now let's stop with the tapping, please. Then I can divide by 6. Get that x equals 3. Okay, so that basically is a question we could have seen on the last test in our last unit. And when we change the equation to now, or the equal sign to an inequality, remember, nothing changes. Okay, we're still going to solve this the exact same way we had done before. Subtract 21, 6x minus 18 equals 0. Add 18, 6x equals 18, divide by 6, and we get to x equals 3. So initially, nothing changes at all. It's exactly what we had done in our last unit with solving equations. But remember that this number is our anchor point. And that anchor point shows up on a number line. In this case, we aren't provided one, so we can make one real fast. When I make an anchor point, it is helpful if we know where 0 is. And your number line, when you're making your own, does not need to be perfect. You could go 1, 2, 3, label where the anchor point's going to be at. And that's really all that I need to see, okay, in terms of the number line. Then we need to decide, do we have an open circle or a closed circle at that anchor point? And it always depends on the symbol here. With this being just less than, it's an open circle. So open circle at 3, and then we're either shading left or right. Now, one thing we talked about last time, and this is where a lot of you have expressed some confusion, is we see less than here. So I'm okay with you having an idea for where you think you should shade before you test a point. So I'm thinking if this is less than, that more than likely I'm going to shade to the left. But remember, there are rules for when that sign flips sometimes. And instead of getting caught up in those rules, we test the point to figure out when that's going to be. So this is where the testing comes into play. So the testing, when I test x equals 0, I'm basically not only testing 0, but I'm testing every other number on the left side of my anchor point. And so if I get a true statement, that tells me all of these numbers on the left side make the inequality true. If I get a false statement, that would tell me all these numbers make the inequality false, and thus I shade the other way. So this 0 is going to get plugged into the original inequality. So that's 6 times 0 plus 3 is it less than 21. So that's 3 is less than 21, which is true. So because when I plug in 0, I get a true statement, that means every other number on the same side as 0, which in this case is the left side, makes this inequality true. So I'm going to shade towards the number I tested because I got a true statement. And again, as we work through more examples today, this is where I want our main focus to be, figuring out where to shade based on testing, not the original inequality sign because it sometimes changes, but really focusing on that shading. Now, the other thing that we can do today to simplify the process is let's just write the number line in interval notation. We don't need to write the full-on inequality. We'll just write the interval notation. So we need to remember that we always write the smallest number first, or the number furthest to the left. That would be negative infinity, and it goes all the way to our anchor point at 3. At 3, we need to decide, is it a squared bracket or just a regular parenthesis? We are not including 3, so it's just a regular parenthesis. So the number line, and then the number line, or the interval notation explaining that number line, is all that we'll work on today. Okay, so let's do a couple more. Again, the main focus being figuring out where to shade. In the bottom left slide, you again have your steps, and I'll give you all a sec to get caught up here. All right, so all of our steps, nothing has changed from what we did in yesterday's lesson. We're just adding one more step into what we need to do for the solving portion. So number 3, let's go ahead and just jump right into it. And you know what? We can even skip getting one side to be 0 today. So not a lot of room. Okay, so first task is to get x by itself. Right now, I don't really care about what the inequality symbol is showing, other than that it's not or equal to, so I know that my anchor point is going to have an open circle. So I'm going to minus 3, give me 3x equals negative 21, then divide by 3, giving me x equals negative 7. Okay, that's the part that all of us should be able to do based on what we had done previously. So I take negative 7 on my number line. It's an open circle because of it being just less than. And right now, with me seeing a less than symbol, I'm thinking I want to shade the numbers that are less than negative 7, which are the numbers to the left. But we don't know that for sure. So again, we're going to test. And I'm testing 0. So when I test 0, I'm basically checking all the numbers that are greater than negative 7 and seeing if they work or not. It all depends on if we get a true or false statement when plugging that back in. So 0 plugged in for x gives me 3 times 0 plus 3, and is it less than negative 18? So that's just 3 is less than negative 18, which is false. Right? That does not make the inequality true. And thus, shading towards 0 is not going to work. Okay, all the numbers that are on the same side of 0, which is the right side of our anchor point, would give us a false statement when plugging them back in. So when that doesn't work, that tells me to shade the other direction. So in this case, that's to the left, which are the less than numbers, matching with where the inequality symbol was to begin with. And so now we just need to write what this inequality is showing. And it's showing all numbers from negative infinity to the largest value we get to, which is negative 7. Just like before, it's an open parenthesis because we are not including negative 7. It has that open circle and not a closed circle. All right. Questions here. Okay, and specifically about the testing of 0 and what that tells us. Because again, that's the main thing I want us to focus on today. Cannon, what you got? To the left? Because when I checked 0, and you know what, just for the sake of testing another number, let's see what happens if we check another number. So let's say we didn't want to test 0. Instead, we test x equals 1. And so when I'm testing a number, I'm testing for, yes, it's just one number, but really every number on that side. So when I check 0 or even 1, I'm asking and checking, do all of these numbers make the inequality true? Well, I figured that out by plugging it back into the original inequality. So 3 times 1 plus 3, is it less than negative 18? That would be 3 plus 3, which is 6. And 6 being less than negative 18 is false. So because we're getting this to be false, that means all numbers on the right side do not make the inequality true, telling us to shade the other side of that anchor point, which is the numbers to the left. So let's say we wanted to see a true statement. Okay, if I plug in, let's say negative 10. I have 3 times negative 10 plus 3, and is it less than negative 18? 3 times negative 10 is negative 30, and then plus 3 is negative 27. So is negative 27 less than negative 18? Yes, right? That one's true. So all the numbers to the left of the anchor point make the inequality true. So we want to shade that side. We're always looking to shade the side that makes the inequality true. And that's why initially, since I got it to be false on the right side, told me to shade the left side. Okay, so if it's false, shade the other side. If it's true, shade the side that you tested. Does that make sense? Let's do another. Okay, because again, this is our main focus for today. When we test, where does that tell us where to shade? And again, the basic rule. If it's false, shade the other side. If it's true, shade the same side. So let's try another one. And then we'll get you all doing some work on your own. Just like before, I'm going to ignore the inequality sign. I can take a note and notice that it's less than, so I'm thinking shade the left. But we'll pick that up in just a second. So I subtract 5. In this case, that gives us 0. So I get x divided by 2 equals 0. To get rid of the dividing by 2, I multiply by 2. 0 times 2 is 0. So we get x equals 0. So now we're going to put our anchor point at 0, and I'm going to do a filled in circle. And now we need to figure out where to shade. Based on where the inequality started, I'm thinking I want to shade the less than numbers, which are off to the left. Okay, but I don't know for sure. This is, again, where we're going to test. In this case, just to, again, try to make the connection, let's test numbers on both the left side and the right side just to see what we're getting and what that might tell us. So let's first pick a number on the left side. Let's do x equals -8. So when I plug in -8, we have -8 divided by 2 plus 5, and is it less than or equal to 5? -8 divided by 2 is -4, and then plus 5 is 1. So is 1 less than or equal to 5? That's true, right? 1 is definitely less than or equal to 5. So that means that -10 works. And so initially, and right now, I'm thinking I need to shade towards that number that made the inequality true. So towards -10. So now when I go and test the number on the right, let's say x equals 8, my guess is I'm going to get something that is false. So 8 divided by 2 plus 5, is that less than or equal to 5? So 4 plus 5, is that less than or equal to 5? So 9, is that less than or equal to 5? That's false, right? That is not true. So that tells me all the numbers on the right side do not make the inequality true. And we want to shade the ones that make that inequality true, which is off to the left here. And so our solution in interval notation are all numbers from -infinity to 0, and this time we use a squared bracket at 0 because of the or equals to. Okay. Are we starting to see the connection with the testing yet? Not yet? Not yet? Again, I can keep saying it. If it's true, shade towards that number. If it's false, shade away. That's all we need to remember. True, shade towards. False, shade away. Okay, we'll continue to work on it and make connections. And right now, ooh, number 5 is kind of nasty. Let's do this. Let's get you all up to the whiteboards and show some work up there just to see what we can put up on the boards. So we've done this before where I'm going to assign each group a problem number. Okay. Let's check our work here. And I'll take a look and see what we put up on the board as well. And I think we're getting closer. Okay, we're getting closer with the whole testing and where to shade. Again, remember that when we get something that is false, that's telling us to shade the other side of the line. Okay, now for some of you, if you're having a hard time still deciding where to shade, I would recommend pick a number on both sides of the number line. So test 2 numbers. Okay, again, we want to shade towards the side that makes the numbers true. Okay, or the inequality true. So after getting the anchor point, as I look up on the board, we're all getting the anchor point perfectly. Okay, and that ends up being 1. When I test 0 now, I end up getting that -1 is less than -9/8. That's like -1.125. That is false, right? Negative 1 is actually bigger than negative 1.125. So since that's false, that's what this x, why I put an x there. That's telling me 0 made that false. So don't shade towards 0. Instead, I shade the other side of the number line, which are the numbers that are greater than 1. So your interval notation, and remember right now with the number line, the interval notation is just the left number, comma, the right number, or the lowest number, comma, the highest number. Okay, so 1 to positive infinity. Then for number 6, a lot of you are picking up that you got negative 14. A lot of you thought that something was off because that's not on our number line. Okay, number lines extend. We can always extend and make it a little bit bigger. Not a big deal. So I added my negative 14 onto the left side of that number line. That is a filled in circle because of the or equals to. And this time when I test 0, I get 63 is less than 161. That's true. So since 0 gives me a true inequality, I want to shade the side that includes 0, which is the right side of the anchor point. So our answers here are negative 14 all the way to infinity. So it's just like the solving part. Let's not even get too caught up in the inequality. And the first thing I'm going to do is distribute the 7. At the same time, I'm going to also distribute the positive 2, giving me 7a plus 28 minus 4a minus 2 minus 3a, and it equals 5. Okay, so make sure when we distribute, we're distributing the number on the outside of the parentheses to everything on the inside. Then I'm going to combine any like terms that I have. So it'd be all the terms with a, so 7a, negative 4a, negative 3a.
That's like 0.
You're right. That is 0a. Okay, so something's going to happen here. Shh, we need to focus up because this is a unique thing that happens. All the a's cancel out. So technically there's nothing left for us to solve for. We need a variable in order to solve the inequality. We're still going to combine the numbers. So 28 and negative 2 combined to be 26. And then we have 5 on the right side. So remember what this meant with an equation. If I got 26 equals 5 and all my variables disappeared, what did we conclude about that equation? Somebody raise their hand and say it loud enough for everyone to hear. Julian, go ahead. No solution. Okay, but that's not necessarily the case yet because we're not checking if they're equal. Rather, we're checking what the inequality is showing us. So in this case, we've got 26 on the left side, 5 on the right side. We're going to bring back in the original inequality symbol. So 26, is it less than or equal to 5? Is that true or false? That's false. Because that's false, now we can confidently say that there is no solution. If instead it had been something like 26 is greater than or equal to 5, and that's true, that tells us that our answer is all solutions. Okay, so just like with equations, inequalities can have no solution and sometimes all solutions. Okay, you know what? Let's stop there. You will have plenty of practice on the homework. And as you're working on the homework,